Previous class we have discussed about a PN junction diode concept, how it will use it as a rectifier, like a forward bias and also reverse bias. Previous classes completed. How a PN junction diode can be used as a rectifier, half wave rectifier and also a full wave rectifier. And yesterday I have compared both also. In case of the half wave rectifier and in case of the full wave rectifier, what are the important formulae and also circuit diagrams and what is the efficiency, all this we have compared yesterday. In this class we will discuss about one of the type of the PN diode, Zener diode. One more nothing but Zener diode. Zener diode. So it is also one of the special type of a PN junction diode. So generally normal diode means we can use it as rectifier. When diode connected in the forward bias, if the given diode is connected in forward bias, if it is ideal, it offers no resistance. So almost a full current flowing through the circuit and that will be useful. When the same diode connected in reverse bias, what will be happen? It offers a high resistance. If it is ideal diode, almost infinite resistance will be offered by the diode. Hence, no current flowing through circuit. So, when a PN diode connected in the reverse bias, there will be no much use. When same diode connected in the forward bias, it has very useful. Correct. Now it has unidirectional property generally. That property only we use it in rectification. But what is already we have the PN diode, then why we have to go for Zener diode? Generally, in reverse bias, normal PN diode is not having much use. That's why by giving a simple modification, the same diode can also be operated in reverse bias. So that's why we have to go for a Zener diode. What is a Zener diode means? Heavily doped. Normal diode having less doping, but in case of the Zener diode, a properly doped or heavily doped PN junction diode, which is operated in the reverse bias, not in forward bias. If you connect in the forward bias, it has a normal function, like whatever normal diode behaves, it also behaves the same way. But whenever Zener diode connected in the reverse bias, it has a special property. That's why a heavily doped or a properly doped PN junction diode, which has a sharp breakdown voltage, is called as a Zener diode. Here I used one word, breakdown voltage. Have you listened to this word? In the previous classes, when diode connected in the forward bias, we have knee voltage or cut-in voltage given concept. Same diode connected in the reverse bias, I have given Zener voltage or breakdown voltage. What is the Zener voltage or breakdown voltage? When the diode connected in the reverse bias, applied voltage at which suddenly the current increases is called as a breakdown voltage, which is also called a Zener voltage. Generally, at a breakdown voltage, what will be happen? Even though current suddenly increases or suddenly decreases, no change of the voltage. So this special property we can use it in Zener diode. Correct? Now, what is a Zener diode means? A heavily doped or a properly doped. Comparing to normal diode, it has heavily doping. A heavily doped PN diode, a heavily doped PN diode, which has a sharp breakdown voltage, is called a Zener diode. So check that one. A heavily doped, not a normal doping. It has a heavy doping. A heavily doped PN junction diode, which has a sharp breakdown voltage, is called as a Zener diode. So generally, Why it is called Zener diode means in the named after a scientist or named after a person. So it was first invented by C. Zener. C. Zener. He is inventor of a Zener diode. Inventor of Zener diode, C. Zener. Here C stands for not necessary Christopher. C stands for Christopher. Why I am using this word means earlier, last year and before last year, while practical exams are going on, at the end of the second year, you are going to attempt second PUC practical exam. In a practicals also we have Zener diode. So we have to conduct experiment and we have to perform the experiment, the student. So at the time of performing the experiment, some Viva questions will be asked. Like 4 Viva questions will be asked. For each question, generally 1 mark. So external will come and internal also will be there. And last time external asked one question: who invented Zener diode? So, but the student correctly answered, I think C. Zener. But unfortunately, the examiner asked what is a C stands for. Generally, we learned about C. Zener only. Who invented means C. Zener. But C stands for means the student also unable to answer, because majority we don't know surname, how we can remember generally. That's why C. Zener he said, but he is unable to answer. But of course, marks not reduced. But the student asked again, so I don't know, sir, can you say what is a C stands for, he asked. But unfortunately, the person who asked the question also don't know, but later that is a secondary. But C stands for what? Christopher. Christopher Zener, correct. That is who is inventor of Zener diode means Christopher Zener. So simply remember C. Zener. And a Zener diode is always operated in reverse bias. So because in reverse bias only, almost a normal diode doesn't allow any current. That's why if you want to get a more current or less current, if you want to maintain the constant voltage, the Zener diode must be connected in reverse bias. There may be question, if you connect in forward bias, what will be happen? Nothing. Normal diode, how it will behave, a Zener diode also behaves same way. There will be no difference. So in the case of the forward bias, in a forward bias, a normal diode, Zener diode, both has same function, both will behave same way. But in the reverse bias, there is no use of normal PN diode, but Zener diode will be having a much use. So it is always connected in a Zener diode, it is connected or always connected in reverse bias. Generally, Zener diode is always connected in reverse bias. In reverse bias also, in a breakdown voltage region, we have to connect it. In a forward bias, what will be happen? In a forward bias, it behaves like a normal, it behaves like a normal PN diode. Normal PN junction diode, whatever the behavior is there, a Zener diode also behaves same way. So there will be no difference. And we can write a symbol. What is the symbol of Zener diode? I'll take a normal diode symbol, I'll give first, but later I'll give the Zener diode symbol. So it is nothing but a normal PN junction diode. It is symbol of the normal PN junction diode. You should write like this. There will be a bar line will be there. Left side P type semiconductor, right side N type semiconductor. So this will be nothing but a symbol of a normal PN junction diode. So this side, bigger side indicates always higher potential, nothing but P type semiconductor. Right side is equal to lower potential, nothing but N type semiconductor, correct? So this total will appear like arrow mark. Arrow mark always indicates a direction of conventional current. But electrons flows from lower to higher potential, positive charges flow from higher to lower potential. So it is a direction. But what is the difference between the normal diode and Zener diode? except this line. Just I am modifying a simple modification like this. Just give a Z shape like this. Check here, a simple modification. Except this line bar Z shape, remaining total will be same only. So you should take it appear like a Z shape, correct? That is only the symbol of a PN diode, Zener diode. Without this Z, only if you write a line, that is the symbol of normal diode, should write. But what is the advantage of the Zener diode? When Zener diode connected in the reverse bias, in a breakdown region, it behaves as voltage stabilizer or voltage regulator or voltage controller. In houses, whenever lines are having up and downs, fluctuating, so that fluctuated voltage can be regulated or controlled by the Zener diode when we connected the Zener diode in reverse bias in a breakdown region. So what is the use means? It is used as a Zener diode is used as a voltage regulator, used as a voltage regulator or voltage stabilizer. That's important. So sometimes 1 mark may be asked, what is the use of Zener diode? A Zener diode can be used as a voltage stabilizer or a voltage regulator or a voltage controller. Correct. That's important. So that's about a Zener diode. General definitions only, general points. So generally, on what factor this breakdown voltage depends. Here we said the breakdown voltage means if you connect the diode like this. I'll draw a simple graph here. I'll take a graph here, x-axis. So this will be y-axis. Here also negative side y dash. So left side is equal to x dash. Always on y-axis will take current. So current I in micro ampere will take generally small current. Left side I'll take a voltage, potential difference V. In a volt will be taken. Correct? That is right side also same. Here also it is a potential difference V. In a volt. Here also it is current I in a milliampere. So this will be forward bias. So this condition nothing but a forward bias. This side will be can take a reverse bias. So forward bias. So this will be reverse bias. So generally when the Zener diode or normal diode, if you connect in the forward bias, what will be happen? So up to the barrier potential, up to barrier potential or potential barrier, there is no flow of current. Electrons and holes cannot cross the junction, cannot combine, no breakage of the covalent bonds, no much availability of free electrons and holes. That's why current will be 0. But later what will be happen? Once if it overcome the barrier potential, the current increases at exponential rate like this. So the current will be moving at exponential rate flowing in the circuit. So here where the current increases at exponential rate, the current begins, that voltage can be called knee voltage or cut-in voltage. Whereas in the reverse bias, whenever the reverse voltage gradually increases, almost there is a small flow of current will be there like this. But after reaching a certain value, what will be happen? The current suddenly increases like this. In the reverse bias, where the current suddenly increases, this voltage can be taken as Vz. That Vz indicates what? Breakdown voltage, or it is also called Zener voltage. Breakdown voltage or Zener voltage. So a Zener diode always we have to connect in reverse bias in breakdown voltage. But here what will be happen? Once if the breakdown voltage reaches up to breakdown voltage, there will be no much minority carriers. Majority carriers, electrons and holes are moving away from the junction, and only minority carriers are moving towards the junction. Small current flows in the circuit. Once if it reaches the breakdown voltage, what will be happen? Suddenly more covalent bonds will break, more number of holes and electrons are available, and the current sharply increases or suddenly increases. But even though current increasing or current decreasing, but there is no change of breakdown voltage, no change of Zener voltage. So in this case, the Zener would act like a voltage regulator or voltage stabilizer. Suddenly, inside, for example, in houses, suddenly current increases, like instead of 10 ampere, 20, 30, 40, 50 amperes increasing, for example. But even though current increasing, check here, voltage constant. So the TV or maybe a refrigerator or maybe AC or computer, such type of electronic devices can be protected even though suddenly current increases. If for example, suddenly voltage in the line decreases, current also decreases, but even though current decreases, what happens to voltage? Remains a constant. That's why in such a way, we can control the voltage or we can regulate the voltages. That is only the function of the Zener diode. But on what factor this Zener voltage depends or breakdown voltage depends means? It mainly depends upon Zener voltage mainly depends upon what factor? Amount of doping. If for example, more doping is there, I used the word heavily doped. The depending upon your proper doping also we can say, if a more doping is there, what will be happen? More doping means thickness of the depletion layer become very thin. Whenever thickness of the layer is very thin, easily the electrons and holes can cross the junction, and at a lesser voltage only breakdown takes place. So whenever doping is more, amount of doping is more, then what will be happen? Breakdown voltage will be less. At less reverse voltage only breakdown takes place. Much current flows in the circuit, and the thickness of the layer will be very less, thin. If for example, amount of doping is less, whenever doping is less means what will be happen? The thickness of the layer will be more. Thickness of the layer is more means automatically more voltage is to be required. So that means automatically at a higher voltage only breakdown takes place. So that's important. On what factor breakdown voltage or Zener voltage depends. You have to remember. So right, one more point. Breakdown voltage depends upon breakdown voltage depends upon breakdown voltage depends upon amount of doping, depends upon amount of doping, it depends upon the amount of doping. That's important. One more point, if it is heavily doped, next point, if a Zener diode is heavily doped, if a Zener diode is heavily doped, then the thickness of the depletion layer, then the thickness of the depletion layer, thickness of the depletion layer decreases, thickness of the depletion layer decreases, and breakdown takes place, and the breakdown takes place at lesser reverse voltage. Breakdown takes place at lesser reverse voltage. Breakdown takes place at a lesser reverse voltage. Next point. Next one more. If the Zener diode is lightly doped, if the Zener diode is lightly doped, then the thickness of the depletion layer, thickness of the depletion layer increases, thickness of the depletion layer increases. Thickness of the depletion layer increases and breakdown takes place at higher reverse voltage. Breakdown takes place at a higher reverse voltage. Breakdown takes place at a higher reverse voltage. That's all. Now we'll discuss how a Zener diode used as voltage regulator or voltage stabilizer. Right, next one. Put the heading Zener diode. Zener diode as a voltage regulator. Zener diode as a voltage regulator. Zener diode as a voltage regulator. Zener diode. Question may be asked, explain how a Zener diode can be used as a voltage regulator. Explain how a Zener diode can be used as a voltage regulator or a voltage stabilizer. I'll give simple diagram. A diagram will give circuit diagram. Here one resistance. Here Zener diode will be connected. So this will be Zener diode. And across the Zener diode there will be load resistance RL. So this will be parallel connection like this. One load, always through the load we can take output value. So this will be load resistance. This will be resistance connected in series. I'll write this will be RS or R, you can write. But here there will be input. So here we are connecting a input voltage. So this will be V input. So V input will be connected here and output can be taken across the load resistance always. Correct. Output can be taken across the load, but input can be passed through this one. Correct. So this will be Zener diode. Symbol also given. It is a P-type semiconductor. So this side N-type semiconductor. Series resistance, load resistance, and it is equal to Zener diode. And the voltage across the load resistance I'll take VL. That indicates potential difference or a voltage across load resistance. But a voltage across Zener diode is equal to Vz. That Vz indicates voltage or potential difference across Zener diode. Generally both are parallel connected. Whenever both are parallel connected, potential difference will be same. But currently different, potential difference same should take. So VL value, Vz value both are equal. There will be no difference. Both are equal exactly. Now, it is nothing but input voltage. Whenever if you switch on the input voltage, one side may take plus, one side may take minus. But how to connect here? Upper part I will take plus. I will take upper part as plus positive terminal, lower part as negative terminal. Now check here. This lower part negative terminal connected to P-type semiconductor. Check here, this one. So negative terminal of the given input source is connected to P-type semiconductor of the Zener diode. Positive terminal will be connected to N-type semiconductor of the Zener diode. Then check here. Then how the diode will behave? reverse bias. So the Zener diode must be connected in reverse bias condition. That's important. Now, if you switch on this battery or source, current will be flowing like this. Here also we can write what is the potential difference here means I'll take this will be Vs, voltage across the resistance equal to Vs. Now whenever current is flowing along this direction, here total current is equal, I'll take I. Total current passing is equal I. So this current is divided into two branches at this point, two parts. Some of the current flowing through Zener diode, remaining current is flowing through the load. The current flowing through load resistance equal, I'll take IL. So this will be equal to IL, current flowing through load resistance. But current flowing through Zener diode is equal, what we should take? IZ. So here the total current divided into two parts. Some of the current flowing through Zener diode, remaining current is flowing through the load resistance. But again, both will be combined here. Then total current again we should take same. So total current passing is equal, what we should write? It is equal IZ plus IL will be added, and the total current is equal to I. We should take. That is only the diagram. So this diagram we have to draw in exam. 1 mark for diagram. Check here once again. Zener diode can be used as a voltage regulator or voltage stabilizer or voltage controller. The circuit diagram used for Zener diode as a voltage regulator is as shown in the figure. The circuit diagram contains one Zener diode and also one series resistance, one load resistance and one input source. So here the Zener diode, parallel to the Zener diode, a load resistance RL is connected, and series to the Zener diode, one resistance RS is connected, and all are connected to the input source. So here a p-type semiconductor of the Zener diode is connected to negative terminal, n-type semiconductor of the Zener diode connected to positive terminal, so that we can say it is in reverse bias. The Zener diode is reverse bias. First, if you switch on this input source, some current is passed through the circuit. Total current passing through circuit is equal to what? I. But this current will be, after flowing through RS, it divided into two branches or two parts. Some of the current flowing through Zener diode, that is IZ. Remaining current flowing through the load resistance, that is IL. If you add both, what will get checked? Total current flowing through circuit I is equal to IZ plus IL. Is it correct or not? Total current in the circuit is equal to I, but it divided into two parts, IZ, IL. If you add both, again we'll get the total current. So I is equal to IZ plus IL, should write. Next, what is the current flowing through, what is the voltage across this load resistance, or what is the voltage across Zener diode? Generally both are equal. Since Zener diode and load resistance, Zener diode and load resistance are in a parallel, Vz is equal to VL, both are equal. Vz value, VL value, both are equal, and that is nothing but equal to output value. So which is equal to V output. So here we can write VL is equal to, formula we can write according to Ohm's law, Vz is equal to IL into RL. Check correct or not? According to Ohm's law, V equal IR formula, but VL is equal to IL into RL, should write. Similarly, what is Vs? Vs is, or it is equal nothing but V input is equal how much? So this will be also called as V naught, output. V naught indicates output. But what is the input value means? This Vs value plus Vz value. If you add both, it is equal total value. V input is equal to Vz plus it is equal to Vs, adding both the values. or we can also write it is equal to Vz is equal to, we also write IL RL plus it is equal to IS, or it is equal to I into RS. V input value is equal to, we can write like this also, or we can write V output is equal to V naught is equal to V input minus Vs, correct? Output value is equal always input value minus whatever the voltage dropped across the series resistance you should take. So V input minus Vs, that is called V input minus Vs is equal to what? Is Rs. V input minus Is Rs. So depending upon given you should take. Here V input is not a fixed value, it is a fluctuated range you should take. For example, 252 or 180 to 250 volt given. We should take one case, you have to substitute 180 value, we should calculate. And the second case you have to substitute 250 value, we have to calculate. So based on the given question, we have to apply the formula. Now, these are the general formula. Now, what will be happen, we have to check. Two cases you have to check. First case. So case 1 you should write. What you have to check, observe means, first after applying the input voltage to the Zener diode, suddenly input voltage increases. Suddenly, for example, input voltage V in value increases. Just I am writing an arrow mark to understand. Whenever the input voltage increases, the current flowing through the circuit also increases. Automatically, current I value also increases. Whenever input voltage increases, the current flowing through the circuit also increases. Whenever current flowing through this series resistance increases, what will be happen? Current flowing through Zener diode also increases. Here more the current means more the voltage will be dropped. Here the current flowing through Zener diode also increases. So current flowing through Zener diode Iz also increases. But even though current flowing through Zener diode increases, but already mentioned where we are using a Zener diode? In reverse bias in a breakdown region. In case of the reverse bias breakdown region, even though current increases, what will be happen? No change in Vz value. So the voltage across the Zener diode remains constant. But here Vz remains constant. No change in Zener voltage. Whenever Zener voltage remains constant, same voltage will be maintained across the load resistance also. Here for example 220 volt is there, here also 220 volt. Here 230 is there, here also 230. So same voltage will be taken across the load resistance as output. So observe carefully, when the input voltage suddenly increases, the corresponding input current also increases. The current flowing through load resistance also, the current flowing through the Zener diode also increases. So even though current flowing through Zener diode increases, the voltage across the Zener diode remains constant. So the same constant voltage will be taken across the load resistance as output. That is the first part. Second case, suddenly for example, the input voltage, line voltage decreases. Whenever the input voltage value suddenly falls, decreases. Normally in houses, for example, 230 volt is there. So 230 suddenly falls to 180 volt. What will be happen? Whenever input voltage decreases, the corresponding current I also decreases. Whenever input voltage decreases, the current flowing through the circuit also decreases. Whenever current flowing through circuit decreases, the current flowing through Zener diode Iz also decreases. But even though current flowing through Zener diode decreases, what happens to voltage? Constant. So but current voltage across the Zener diode remains constant because it is connected in reverse bias in a breakdown voltage region. That's why Vz constant. So the same constant voltage will be collected or taken across the load resistance as output. So observe these two cases. In the first case, voltage increases. Second case, voltage decreases. But here first case current increases. Second case current decreases. First case current through Zener diode increases. Second case current through Zener diode decreases. But in both the cases, voltage across the Zener diode remains constant. So same constant voltage can be taken across the load resistance as output. That's why in this way the Zener diode can be maintained the voltage constant always, and hence it act like a voltage controller or a voltage stabilizer or a voltage regulator, that you have to write. So these 2 points if you remember, but in exam you should not write like this by placing V in I Z, putting arrow marks up and down, no marks will be given. So this first you should draw the diagram, 1 mark, then write about this equations, 1 mark. Later we have to explain about the diagram. After explanation of the diagram, what happens if the input voltage increases, what happens if the input voltage decreases, that part you should write, and the final conclusion. Here one important thing you have to understand, the value of the RS, whatever the resistance we connected here in series, we have to select carefully. The value of RS must be selected in such a way that even though the load resistance, for example, absent, the maximum safe current must be passing through the series resistance. The Zener diode should not be damaged, so that the electronic equipment should not be damaged. That's why even though in the absence of the load resistance, maximum safe current must be passing through only series resistance. That care we have to take. That's important. So the value of the RS should be selected in such a way that even in the absence of the load resistance, maximum safe current must be passing through the series resistance. That is a very important point. You have to select carefully. Correct? That is only about Zener diode, how it can be used as a voltage controller or a voltage stabilizer. So this last 2 paragraphs once again. When the line voltage suddenly, input line voltage suddenly increases, the current flowing through the series resistance also increases. The corresponding the current through the Zener diode also increases. But even though current through the Zener diode increases, the voltage across the Zener diode remains constant. The same constant voltage can be taken across the load resistance as output. Now, when the input line voltage suddenly decreases, the corresponding current flowing through the circuit also decreases. The current through the Zener diode also decreases, but the voltage across the Zener diode remains constant. So the same constant voltage can be taken across the load resistance as output. In this way, even the input voltage increases or decreases, the voltage across the Zener diode and output voltage remains constant. So in this way, a Zener diode can be used as a voltage regulator or voltage stabilizer or a voltage controller. That we should write about a Zener diode. In case of the Zener diode, what will be happen? No change of the voltage. Very important. No change of the voltage. Vz constant. But which parameter changes? Current. So here current may be increased or current may be decreased, but voltage constant. So current can be controlled by here Zener voltage. But what parameter changes in case of the series resistance? When current increases, voltage drop increases. More voltage will be dropped. When current input voltage decreases, current also decreases. More voltage will be decreases. So voltage can be controlled by the series resistance. Current can be here controlled by the Zener diode. Correct? Here more current is there. For example, here also more current is there. Less current passing through load resistance. If less current in the Zener diode is there, more current passing through the load resistance. So that is about a Zener diode. Or 5 marks important question. Explain how a Zener diode can be used as a voltage regulator or voltage stabilizer. That's all. Similar to this Zener diode, means one of the type of the PN diode, it is a Zener diode. In next class we will discuss there are 3 opto electronic devices. So optics means nothing but uses light as a signal. Electronic device means already we know which uses the electrons as carriers. So when we are using a signal as a light, in electronic device that can be called opto electronic device. One is a LED, light emitting diode. One is a photodiode, PD, and one more nothing but solar cell. In calculators or in case of the satellites are using solar cells. So these three next we'll discuss. So they may be asked for 2 marks or 3 marks questions only. What is LED? What is a photodiode? What is solar cell? In which bias we have to connect, and also their symbol, their circuit, and also the simple description, and what are their uses. So that we will discuss in next tomorrow class. And later we have one concept, digital electronics will be there. So in 4 or 5 classes approximately we can wind up this one. Correct. Okay, thank you.